GameSci.com. GameSci.com.
Greetings, space aliens. Welcome to Lesson on Lists, aka Arrays. A list, also known as arrays. A list is an ordered collection of items or elements. If you need 2 or 3 variables, you don't need a list. But what if you needed 200 or 300 variables? Yes, very much you would need a list. You can access the collection as a whole, or you can access the individual elements of a list. Lists are similar to an array in other programming languages, but not exactly the same thing. A list is much more dynamic. An array is usually a set, fixed size. A list is very dynamic and can grow as needed. Creation of the list money list. When you see the square brackets, read as list. Money list is a list of float numbers. Beginners are most confused that a list starts at an index or subscript of 0. The first element of a list is at position 0 of the list, not position 1. Let's break this line into each individual element. You'll see that the first item in the list is 20.25. That is inserted into slot 0 or index 0 of the list. The next element in the list, 19.0, that is in position 1 or subscript 1 of the list. The third element is at position 2. Do you see the off by 1 problem? Since the list starts at position 0, the first element is at position 0. The third item in the list is at position 2 of the list. 82 is the next element. This is called an initialization list. These are the initial values that I want to store in my list, and 82 goes into subscript or index 3 of my list. 4.75 is the last element of my initialization list. This is a 5-element list where the last position is at 4. The first thing we'll learn to do with a list is how to pull information out of a list. How to pull a value out of list at index 0. Go to the money list and at list index 0, extract the value and assign it to the variable player money. And you can see what's in position 0 of the list gets pulled out and assigned to player money. Insert a value into the list. This time use subscript 3. Take the value that's in player money and assign it to money list at indexed or subscript 3. And you can see the 20.25 gets assigned to money list at index or subscript 3. Let's use the list to do some calculations. First thing we'll do is we'll access money list at subscript 4. So the 4.75 gets pulled out of the list. We add to that 5.50 and the result is 10.25. What do we do with this 10.25? It's assigned back into list at subscript 4. And 10.25 replaces the current contents of slot 4 of the list. Remember, it used to be 475. It has now got 10.25. We are extracting values from the list and we are inserting values into the list. You'll see that you can use a list variable just like you could use any other variable. Notice how we use player money. We put something into player money, we take something out of player money. We're doing the same thing with money list. We're doing money list position 4. We take something out of money list position 4. We insert something back into money list position 4. Similar line of code. We will access money list at index or subscript 1, the 19.0. We'll subtract 12.25 from that and calculate 6.75. What do we do with the 6.75? We insert it back into the money list variable at position or index 1. The 6.75 is assigned into the list at index 1. I hope you're getting the picture here that the variables that make up a list are the same as any other variables. Just like you can put something into a plain old variable and pull something out of a plain old variable, the only difference when you're using a list is you have to use what's called subscripts. In the square brackets, you have to identify which element of the list you want to access. Which element of the list you want to replace. Assignments into a list are destructive. It means if I assign a new value into money list 1, the old value in money list 1 disappears. That was our quick introduction to lists. How do you initialize a list? How do you pull values out of a list? How do you put values into a list? In the next slide, we'll learn a lot more about lists. Creating lists. Turns out there are 3 different ways to create a list. Number 1, we can create an empty list and dynamically grow it. The big difference between a list and an array from another programming language: an array in another language is a fixed size. You give it a size of 100 and it stays the size of 100. Not so with a Python list. A Python list can start at 0 size and grow as needed. The second way that you can create a list is you can create and initialize it. We saw this on the last slide. You can create the list and initialize it with values at the same time. The third way to create a list is you can fill it all with same values. So you can create a list and say fill it with all zeros or fill it with all -1s. We'll look at all 3 ways of creating a list in this slide. The first way to create a list is create it as empty and dynamically grow it. So hand equals square bracket end of square bracket semicolon. That will create an empty list, a list with no items in it. In Python, lists are dynamic. They can grow as needed. This is where a list is different than an array in other languages. Arrays are a set fixed size. In Python, nothing is set or fixed about the size. It can grow anytime it wants. So we'll set up a hand variable, and basically I'll put the word empty in here to say this is an empty variable, and we'll grow it as we need it. A quick note about lists. Lists are reference variables. We talked about objects before. The actual object variable is a reference to another thing. Well, hand will be a reference to a list object. And let's see the list object now. This approach mimics dealing cards from a hand. Players in a card game start with an empty hand, but as a card gets dealt from the deck, it's appended or added to the player's hand. So we started with the empty hand with 0 cards in it, and we'll call append to add 1 card to the hand. If I had room, I'd call more to mimic more cards being dealt to the hand, but I don't have room on this slide for that. Lists are dynamic. They grow as needed. Python lists are objects. Notice how hand is a reference to this list object. This list object happens to contain 1 item, 44 in it. The second way to create a list is to create and initialize the list with an initialization list in square brackets. We saw this on the previous slide. We're doing it again. This time, when you know what you want to put into your list, when you have the values that you want to put in your list, you can create it and initialize it at the same time. Keep in mind, lists are objects. The values 0 through 9 are stored in the object. They're not stored in the hand variable. Hand is a reference to that object. It points to or refers to the object. After the object is created with the values in each slot, the object is then going to be assigned a hand. This piece of code right here creates the list object with the 5 numbers in it. The assignment operator is what actually attaches the list object to the hand reference variable. Hand is a reference to a list object that contains the values 0, 2, 5, 6, 9. In object-oriented programming, OOP, Python lists are objects. Python strings are objects. Technically, all Python variables are objects, but we'll study Python lists and Python strings first and how they interact as objects. The number one thing you have to understand about an object is the object variable, hand, is a reference. It does not contain the numbers of the list. It contains a reference to the object, and then the object contains the numbers in the list. Going back to our deck of cards analogy, quite often we exchange cards in our hand. In poker, you will discard and replace a card. In Go Fish, you will hand a card over and acquire cards. How do we change a card in our current hand? We go hand subscript 0 equals 14. Replace whatever was in position 0 of the list with a new value of 14, and you can see if 14 is inserted into our hand. Well, what if we have to tell somebody about a card in our hand? We can go to the hand, index 4 and extract what's in there and assign it to the variable card. What we'll do is follow this arrow. I purposely passed it through slot 4 of the list because I wanted to say, well, we're going to grab what's in position 4 of the list and assign it to the card variable. And the 9 is copied from hand position 4 into the card variable. As you can see, we used list variables just like we use any other variable. Let's replace another card in the list. Let's assign the value 51. Remember, 51 represents a single card in the player's hands, and assign it to slot or index 2 of our list. And a 51 replaces what was in position 2 of our list. Use the len function to access the size of the list. The size of this list is currently 5. We've seen this function before. We saw it with strings. The len function with a string would tell you how many characters are stored in the string. The len function, when you pass it a list, will tell you how many items are stored in the list. Currently, this list has 5 items, so it returns a 5 and assigns it to the variable count. The len function is used with any object that has a countable number of items in it. We keep seeing it because it's used over and over with many different types of objects. At the start of this slide, I promised you 3 different ways to create a list. Here's a third way to create a list. Let's create and fill with the same value. A deck of playing cards would have to be represented with a list of 52 slots. So what we're going to do here is create 52 slots with the initial value of -1. I'll say deck equals square bracket -1 end of square bracket times 52. What this is saying is I want 52 -1s. I want a list with 52 slots, and each of the slots shall contain a -1. Keep in mind, deck is a reference to a list object, so it will point to this list, and this list will have 52 slots in it, each containing the value -1. If I'm going to store a deck of cards, I need 52 slots. I just picked -1 as initial value. I could have started it at 0. I could have started it at anything. I assume as I shuffle the cards, I'll put different numbers into each 52 slots. And then as I'm dealing cards, I will deal out the cards from there. There you have it. 3 ways to create a list. When you are using a list in your program, you've got to decide, do I want to start it empty and add individual items? Do I want to start with a set fixed value? Or do I want to create a big empty list right at the beginning? There is a slight advantage to pre-allocating the slots of the list. It might save you a little bit of time because the program doesn't have to dynamically add to the size of the list. Also, there are algorithms that depend on a fixed size list, and you'll want to create your array like this if you're using one of those algorithms. This way of creating a list more represents the way an array works in other computer languages. In other languages, you have to set the size of the array at the beginning, and that's what this line of code does. Parallel lists. This is a way to use lists where you set up 2 lists and the corresponding items in each list match each other. A parallel list is when you have 2 or more lists where information in an index or slot corresponds to the same index in another list. So slot 1 of the player's list elk aligns with slot 1 of the money list 19. See this arrow right there? It implies that elk has current money value of 19.0. Let's create the player's list with an initialization list of Viper, Elk, Bond, Born, and Powers. You can see quite a bit happens on this one line of code. A reference variable players is created. An object with 5 slots is created, and each of those 5 slots is filled with a string value, Viper, Elk, Bond, Born, and Powers. That one line of code does an awful lot in computer memory. Next, we set up the parallel list money and give it an initialization list. And you can see a lot happens when you provide an initialization list. The money reference variable is created and it is assigned to a list object with 5 slots in it. And each of those 5 slots is provided an initial value. Slot 0 gets 20.25. Slot 1 or index 1 gets 19.0. Index or subscript 2 gets 27.5, and so on down the line. Each slot gets a corresponding value. Now here's where the parallel list comes into play. That 20.25 is the current money amount that player Viper has. That 19.0 is the current money amount that Elk has. 27.5 is for Bond, 82 is for Born, and 4.75 is Power's current money value. Do you see what I mean by a parallel list? I have two separate lists, but the index for both lists match each other. Let's run a few lines of code and see how parallel lists work. Output on the screen, enter a player number 0 to 4, and out on the screen comes the prompt, enter a player number. Slot equals the integer input of 1, get some keyboard input from the user, then use that variable to access the information in the parallel arrays. Print the player on the output, then go to the player's slot number to acquire their name, and slot 1 contains an elk, so an elk shows up on my output, has $, and then go to the parallel array, money, and in the same slot, get the current balance of that player. Do you see how parallel arrays work? Once I have the index of the player's name, I have the index of the money that that player has acquired during this game. Let's do it again just to try a different index. So start over with a new index. Output the prompt to the screen. Go get the keyboard input, convert it to an integer, and this time they input a 4. Well, 4 selects this slot of the parallel arrays. When we do our output, we'll go to player, and in slot 4, we'll see that player's name is Powers. And we'll say has $, and we'll go to slot 4 of the parallel array, get the 475, and output the current balance of the player Powers as $4.75. You can see I boxed out the two array slots that we're accessing. That's why they're called parallel arrays. Every slot in player's list corresponds to a slot in the money list. Try it one more time. Start over with a new index. This time the player inputs a 0. I want to see what player Viper has in the bank account. I boxed out where we're accessing the parallel arrays here. Player Viper from slot 0 has $20.25. You'll see that I'm accessing the Viper's money in their bank account right there. Let's try it one more time. I promise this is the last try because I wanted to try something that's not quite right. This time, when the player inputs a number, they were supposed to enter a number between 0 and 4, and I guess just to be mean, they entered a 5. Never count on users inputting the right thing. No matter how often you tell them enter a number between 0 and 4, they very well may enter something completely different. This time they did a 5. You'll see what I boxed out here. The problem with 5 is it's off the edge of the list. There is no slot 5 or index 5 in either of these lists. When we go to print it out, we're trying to print error. It doesn't exist, and we will get a big, nasty, ugly error message on our output. And probably terminate our program and say we're not running anymore. It's some sort of index out of bounds error. And that's it. You're done. Your code is not executing. This just brings up a point that it's important to verify user input. Never ever assume just because you told the user to enter a number between 0 and 4, they will enter a number between 0 and 4. So that's player lists. It's one of the ways you can use lists in a computer program. Next up is the linear search algorithm. This is computer science after all, and I feel the need to show you an algorithm. It's also a good example of Python coding. Linear search is a brute force algorithm that loops through the entire list looking for a value and returning its position in the list, or -1 if it could not find the value in the list. I went ahead and preset up the list for us so we don't have to go through that again. This is a call to linear search. Pass arguments, myList and the key 50, two parameters, data and target. Find 50 in the list. The key contains the value 50, so we'll pass the list to data, and we'll pass 50 as the argument to target, and basically we're asking it to find 50 in this list. It's important to know that target is passed by value. It's a copy. Any change to target would never change the key. Data is passed by reference. No copy of the list is made. Any change to data would change my list. If you pass a list as a parameter to a function, be careful. Anybody you pass a list to could possibly change your list. Now, I didn't do it in this example because linear search has no business changing the list, but keep in mind it is possible. There's two ways to send parameters: pass by value, in which a copy of the parameter is made, and pass by reference, where it doesn't make a copy. Can anyone guess why it doesn't copy a list? That's right, because a list could be very big. What if you passed a list of 1,000,000 numbers? You don't want to make a copy of 1,000,000 numbers. Turns out in Python, simple data types like int, float, and str are passed by value. It goes ahead and makes a copy of those. Those are small and easy to copy. More complex objects, like lists, are passed by reference. In that situation, it does not make a copy of the parameter. Executing the code, we'll do a for loop. Index will start at 0 because that's the way the range function works. The default starting value is 0. And a range of 5. Now, why do I say a range of 5 here? Because the length of data is clearly 5 items. The length function will tell you how many items are in the list. It will return a 5. We'll end up doing a range from 0 to 5, which means we will index through 0 through 4. The range function does not include the last number, so this will range from 0 to 4. Lists are why range 5 stops at 4. The last element of a 5-element list is at position 4. That's why the range function of 5 stops at a 4. Index will start at 0, and you'll see index has a 0. Our key is 50, which was passed as a parameter, so target contains a 50 at this point. Index 0 is in range from 0 to 5. That is a true statement, so we will go inside the for loop and execute the code inside the for loop. Now we're looking for a match here. Does the target match data at index 0? 50 is our target. Data of index 0 is 20. 50 does not match 20. This is a false statement. As a false statement, we will skip past this code and we'll hit the end of the for loop. Why is this the end of the for loop? Because the indented code stops. If the indented code stops, we are at the end of this for loop, and we will return straight back up to the for loop without doing anything. A plain if statement will either execute this code or skip this code. When it skips the code, it hits the end of the for loop and comes right back up. Index is automatically bumped to 1. Index equals index plus 1 equals 1. The default behavior of the range function is to add 1 to index every time. We'll move over to the next index of the list, which is 1. Index equals 1 is in range. 1 is properly in the range, so we'll return a true. And if we get a true statement for the for loop, we will go inside and execute the code in the loop. If target equals data of index, do we have a match? Question mark. Well, the target is 50. Data at subscript 1 is 30. 50 equal 30 is a false statement. So once again, we will skip the indented code. We'll hit the end of the for loop. And at the end of the for loop, we spin back up to the for loop. Index equals index plus 1. We bump the index. The default behavior is to just add 1. Index becomes 2. A for loop is a true-false statement. Are we still in range? If that's true, we will execute the code in the for loop. If that is false, we will leave the for loop. An index of 2 is in the proper range. Turn true and execute the code in the for loop. If target equals data of index, index contains a 2, so we're asking is 50 equal to 50? You can see clearly index 2 contains the value 50. Guess what? That matches our target. We finally have a true statement. As a true if statement, we will go inside and execute the indented code. I think we found a match here. Return index. We found it. Woohoo! But we're not returning 50. That was our target. We're returning the position in the list of 50, which is index. 50 is located at position 2 of the list. So we take the 2 out of index and we return the 2. Who gets the 2? Whoever called linear search. Go back to this equal sign in front of linear search. That's who gets the 2. Linear search was a success. The key 50 was found at slot or index 2. The slot equals here says slot will equal the value 2. We found it. Notice also that the local variables got deallocated. The data variable, deallocated. The target variable, deallocated. Local variables like data and target disappear after the linear search. But what we were looking for, which slot was 50 found in, that's safely in the slot variable. We'll look closer at the local variables on the next call to linear search. Let's do a linear search again, and this time for a value not in the array, 25. So we'll set the key to 25, and the thing about 25 is it's not there in the list. Let's see what happens when we search for something that is not in the list. Let's call linear search. Let's pass the arguments myList and the key 25 to the parameters data and target. Find 25 in the list. So myList is a reference to this entire list of numbers. It will be passed to and assigned to the data variable. Key contains a 25. The value 25 will be assigned to the parameter target. Now look what happens with the local variables or the parameters when we complete the call. Target is passed by value. It's a copy. Any change to target could never change the key. Notice how target was dynamically created. Local variables are created when you call a function. Target was dynamically created with a copy of the 25. Key and target are two separate variables. Data is passed by reference. No copy is made. Any change to data would change the list. Now look at data over here. It is not a copy of the list. It's pointing to or referencing the exact same list. That's what pass by reference means. Data will point to the exact same thing as myList points to. So we have access to the numbers, but if we change any of them, they'd be changed permanently. In Python, simple types like int, float, and str are passed by value. That's why target is a copy. In Python, a list is passed by a reference. That's why it does not make a copy of the list. Index equals 0 in range of 5. We will initialize index to the default value of 0. Index is a local variable, so it dynamically gets created as soon as we use it. 0 is definitely in range. So overall, index is in range is a true statement. We will go inside the for loop and execute the code in the for loop. Target of 25 is equal to data of index. Index is 0, so target 25, does that equal the 20 in position 0 of the list? The answer is false. It will skip the indented code, hit the end of the for loop, and pop back up. Index is bumped to the next slot, 1. Is index equal to 1 in the proper range? It certainly is. So that's a true statement. We will go inside the for loop and execute the code in the for loop. Target equals data of index. Target is still 25, but data of index is now 30. That does not match. That's a false statement. We will skip the indented code and return to the for loop. Index equals index plus 1 or 2. 2 is definitely in the proper range. So index of 2 is in the proper range. That's a true statement. We will go inside the for loop. Now we're looking at target of 25. Does that equal index subscript 2 of 50? And that is a false statement. As a false statement, we will skip the indented code, hit the end of the for loop, and come right back up and do the for loop again. Index equals index plus 1 or 3. It looks like we're still in range. As a true statement, we are in range. We will go inside the for loop and execute the for loop. Target of 25 does not match data of index, which is 10. Look very carefully. Index of 3, that value 10 compared to 25 is definitely a false. So once again, we'll skip the indented code. We'll hit the end of the for loop and pop right back up. We're going through the entire array here, folks. This is a not found condition. This is the worst case scenario for linear search. When an item is not found, you have to go through everything in the array to determine that. So index goes to 4, which is still in range. 4 is a good value when you're ranging to 5. 4 is in range, so this returns true. As a true statement, we will go inside the for loop and execute the code inside the for loop. Once again, we do not have a match. Our target of 25 does not match data of index 4, which is 40. So this is a false statement, but things are going to be different this next time. We'll skip the indented code. We'll hit the end of the for loop, pop back up, and do the for loop again. Index equals index plus 1 are 5. Remember, length of data returned to 5, but 5 is excluded from the range. So when we get an index of 5, that is not in range, and that is definitely a false statement. As a false statement, what does the for loop do? It skips the indented code. It leaves the for loop. When it leaves the for loop, it'll return a -1, and -1 is simply a flag. A flag to tell us we did not find the value you were looking for. 25, our original target, does not exist in this list. Linear search failed. The key 25 was not found. We returned a -1 and we assigned it to slot. So slot containing a -1 after this search is a big giant red flag saying I could not find the key you were looking for. Also notice what happened. Once linear search fully returned and assigned a value to slot, our local variables deallocated. Target went away, data went away, index went away. That's what happens to local variables when a function is done. There you have it. That's the linear search algorithm. I thought it was a good example of using Python functions and for loops to see how they work. We'll move on to the next topic. Python dictionaries, aka associative arrays. Other languages might call these things associative arrays, but Python very clearly calls them dictionaries. Other languages might even call them hashes, but once again, Python calls it a dictionary, so that's the term we'll use. A dictionary is an unordered collection of items or elements. Store data in key value pairs. Use the key to access the data, like a list uses a subscript or index number. Dictionaries are similar to lists, but lists use a simple number to identify what you want to access, and dictionaries use a key. You can access the collection as a whole or individual elements. It's called an associative array in some programming languages. Some languages also call them hashes, but Python clearly calls these things dictionaries, so we will use the term dictionary for the language Python. Okay, let's start. This is going to be a complicated slide, a lot of stuff in it. So I pre-drew some of the stuff on the screen, so I didn't have to do it while we're going through the slide. Creation of the dictionary diction. This one line of code is going to set up and create a dictionary with 3 items in it. We use curly braces for a dictionary. One of the few places that Python uses the curly braces. Remember, other programming languages use curly braces all over the place. Python, this is one of the few places where we use curly braces. A list uses numbers in square brackets. A dictionary uses keys. In the square brackets, we will put a key value to identify the element we want to access. This, of course, is very similar to how we set up a list, except a list uses square brackets. Now let's see what this creates in computer memory. Diction, of course, is a reference to an object, so it will point to the dictionary object. So let's go through this line step by step. The first thing listed in our dictionary is name : Zork. That means we want name to be the key, and the value associated with that key will be Zork. And you'll see it's stored in the first row of our dictionary. Next up, we want to set up a key species to access the value orc. So species will be the key to access the value orc in our dictionary. Finally, we'll use the key health to access the value 100 in our dictionary. So we ended up with a dictionary with basically 3 items in it: name Zork, species orc, and health 100. This is a dictionary, and rather than using a number or subscript to access the data stored in the dictionary, we'll use a key to do it. Diction square bracket, name in quotes, end of square bracket. Name is the key. Go into the dictionary and find the key name. Once you find it, extract the value listed under name. So it will return the value Zork. And the Zork gets assigned to the name variable. We just pulled something out of our dictionary using the key name and assigned it to variable the name, and you could see Zork showed up in our variable the name. This is an example of extracting something from the dictionary. Pull a value out of the dictionary. Next up, let's put something into the dictionary. Take a new value, dork, and assign it in the dictionary under the key species. Well, this originally was orc, and we replaced the value of orc with the new value dork. Get it? Get it? Zork the dork? Is that funny? Probably not. Anyway, just like with a list, you could pull stuff out of the list and you could put stuff into the list. These two lines of code are examples of pulling something out of the dictionary using the key name and putting something into the dictionary using the key species. Doesn't matter whether you use double quotes or single quotes. Python will handle either one. Remember, a string in Python can be in double quotes or single quotes. It doesn't matter. And of course, we can do both on the same line. We are going to access our dictionary, diction, and using the key health, extract the current value of health, which is 100. Once we have extracted the 100, we will subtract 10 from it and calculate a 90. That 90 will then be assigned back into the dictionary using the key health. The 100 got replaced by a 90. Using a dictionary is not much different than using a list, except you use a key to access the elements instead of using a simple subscript like 0, 1, 2, or 3. Here's a way to access all the keys in a dictionary. I'm going to go to diction.keys. Remember, a dictionary is an object reference. Remember this syntax. Go to the object reference diction. The dot says go inside that dictionary, and keys is a method inside that dictionary that will return all the keys stored in the dictionary. And you can see on the output, the key name, the key species, and the key health are returned by diction.keys. This is useful if you want to loop through all the items in a dictionary. You can also access all the values in a dictionary. Once again, I'll go to the diction reference right here. A reference variable points to a dictionary object and extract the values from that dictionary object. So it'll grab all the values in the dictionary object and return them. And you can see Zork, dork, and 90 are returned from the object, the dictionary object. This is useful if you want to loop through all the values stored in the dictionary. There you have it. That's a simple introduction to dictionaries. Dictionaries are a choice. A lot of times we'll use a list or a parallel list. Sometimes it's more useful in using a dictionary. I find it takes a little getting used to dictionaries, but once you start to understand them, they can cut down on the complexity of the code quite a bit. I really like to use them. That's it for this variable. Hopefully now you understand a little more about lists and a little more about dictionaries. As we proceed in the lessons, we'll touch on them more as we keep going. Thank you. Good night. Have a great day. Adios, space aliens.